Okay, so picking up right where we left off last day. Okay, so last day I introduced to you what a polynomial is, and we looked at the constant function, the linear function, the quadratic, and the cubic. And we covered all the elements of them. So we talked about x-intercept, y-intercept, number of turning points, ending behavior, so quadrant 1, quadrant 3, that stuff, domain and range. Okay, and we filled in our little charts. Okay, so I said to you, you don't have to have those charts memorized. If you want to remember that linears have no turning points every single time, you're more than welcome to memorize that pattern. But if you'd rather just plug the equation in on the calculator, look at the picture, and then answer the questions, that works as well. Using the calculator is a little bit more time consuming because you've got to physically plug it in every time. The key though is you have to know what a turning point is. You have to know what I mean when I say end behavior. So you have to still know the terminology even if you're just using the calculator to get yourself through it. So what we're going to do today is we're going to cover two more words, actually just one more word, leading coefficient. And then we're going to talk about some of the patterns that are always going to be there. And then we will do some examples and then we'll call it a day. Okay? Okay, so leading coefficient. So you should know what a coefficient is. So a coefficient is the number in front of the letter. Okay, so on this example right here, -4 and -5, these are coefficients. Okay, the numbers in front of a letter. You know that word, you've seen it since about grade 9. Now, the leading coefficient is the number in front of the letter that has the largest power. So, right here, x squared is my biggest power. So there is a 1 in front of that x squared. So 1 is the leading coefficient. -4 and -5 are just plain old coefficients. Okay, so the leading coefficient is 1. Okay, so on the next one, so x is the highest power, x, the number in front of it, so the leading coefficient is 2. Okay, so in the next one, which one of the terms has the highest power? X cubed. So the number in front of it is -10. So -10 is the leading coefficient. Okay, now, why do we care about it? You're going to care about it in about a minute and a half because the leading coefficient controls something very, very specific on all the graphs. Okay, there's a pattern to them. Okay, second pattern, constant term. So constant term is the number in the equations. It's the one that's got no letters with it at all. So the constant term, let's use blue. So the constant term is -5, -4, so it's the term that has no letter with it. Now, this one has a letter. This one has a letter. This one has a letter. So none of them have no letter. So think of there being on the end of this, think of it being +0, right? Because adding 0 has no effect. So we say the constant term is 0. So if there's not just a number there, just plunk in the word number 0. Okay? So let's bring all this together and just do a little example here. So degree, remember, is the highest powered x. Leading coefficient is the number in front of it. So I need to create an equation that has a -3 in front of an x squared. And then I can leave it at that. That I'm done. I've checked off all my boxes because it didn't tell me how many terms I had to write out. Okay. Let's say I add into this question that the polynomial also has to have 3 terms. So I need to have 1, 2, 3 terms. So remember, x squared has to be the biggest x. So I could go plus 5x plus 8, something like that. Okay. If it said 2 terms, you would just go negative 3x squared plus 5x or negative 3x squared plus 8. No. Well, yes, you can. Yes, you can, but it would simplify down to still one constant. So that would count as only one term. Right. You want to have, when it says 3 terms, it means 3 distinct terms. Yes. Yeah. So essentially, they can't be like terms. Right. So if you had, so for example, if you had plus 8 and plus 2, that would count as one term because it would be plus 10. It wouldn't count as 2 terms. Yeah. When I say terms, I mean distinct. So different different degrees on each term, different letters. Yeah. Okay. Degree 2, leading coefficient 7, and this one has to have 2 terms. So it has to have 2 terms. You have to have a 7 in front of the x squared. And then we got to come up with one other term. Anything you want. Sure, minus 4x. Or you could just do minus 4. What do you mean by solve? Well, we have figured it out. Yeah, so you don't have to do it like, this is just honestly what it's going to be on the diploma. No, this is going to be a matching question on the diploma. So they're probably going to give you 4 equations and 4 statements. So the statements are numbered 1, 2, 3, 4. And these are numbered A, B, C, D. And it'll be a numeric response. And you'll put the conditions that match equation A, the conditions that match equation B, and you'll just match it up. They love math matching on the 30-2 diploma. And the reason why is they can cover an entire unit. If they have the choices covering every single word we've talked about in that unit, they can literally cover the entire unit in one matching question worth 1 mark. So for example, if I had one statement using degree and leading coefficient, another one using the words x-intercept, y-intercept, another one using the word turning point, and another one with domain and range, and you had to match, that's every single word in this whole unit. So literally in one question for 1 mark, I can cover the entire polynomials unit. Okay. Like they're big questions, but they're not hard, but you have to know what the words mean. Okay. Okay. Degree 1. So what does degree 1 mean? Just an x. And what has to be in front of that x? 1. Now, it didn't say how many terms you needed. No. So you could leave it like that, or you could add on, let's say, 3 on the end and make it a 2-term thing. Could I add on a 3x squared? No, because the highest powered x I'm allowed to have is an x to the 1, right? Degree 0. Okay, degree 0, this means your constant function, or in other words, it's just a number. Degree 0 means no x at all. Degree 3 with a constant term of -8. So degree 3. So you can put any number you want there other than 0, or just leave it as a 1. And then you can put anything in the middle if you want. So you could put x squared terms and x terms if you wanted. But you have to finish off with a subtract 8 because that's the constant term on the end. Okay, so you could leave it as x cubed minus 8. That has matched all the conditions. I can make it 5x cubed plus 7x squared plus 2x minus 8. That matches all the conditions. Okay, so you're allowed to have more than what it's saying, but you can't have less than what it's saying. Okay, so question on the word degree, leading coefficient, number of terms, constant term. You're okay with that? Okay. Okay, let's get into some patterns. Because the patterns are ridiculously helpful when you're using your calculator to make sure that you've done it correct. Okay, I mentioned this pattern yesterday to you, but we'll go through it again. So the constant term will match the y-intercept of the graph every single time. Now, if you forget this pattern, can you plug this in on your graphing calculator and use number one value to find it? Yes. Or you can go past go, collect your $200, and go -3, y-intercept -3. For this one, constant term is +1, so the y-intercept is 1. Again, if you plug this into y1, you went to number one value, you will see that the y-intercept's at 1. What the patterns do is they just take out a whole bunch of button pushing for you. They just make life so much easier, okay? So on this one, the constant term is -2, so the y-intercept is -2. Again, if you were to use your graphing calculator and graph this thing, you would see that it has a y-intercept at -2. Okay? But knowing that, and you actually learned that pattern in grade 11. I know you remember everything from 20-2. But in 20-2, we focused on quadratics, and this was one of the patterns that we taught you, was that the constant term was the y-intercept. I'm just letting you know that, hey, it's true for every function. It doesn't matter what we huck at you, the number on the end is always the y-intercept. Are you good with that? Okay, leading coefficient. Okay, this one's my favorite. Okay. Okay, the leading coefficient affects how the graph ends on the far right side. Okay, so if the leading coefficient is positive, on the far right side, the graph is going to finish by going up. If the leading coefficient is a negative number, the graph is going to finish by going down on the right-hand side. So we can see on these two examples here. So both of them have a leading coefficient of -1 and -0.5. And they are both heading down to the right. Whereas on this one, the leading coefficient is +0.5, and they both finish by going up to the right. Now, I'm going to teach you one more pattern that's not in the notes, but it is super handy to know, okay? And it's called counting legs or counting arms, okay? What we do is we take the degree. So the degree for this one is 3. Okay, I'll give you a second to catch up here. You guys are all highlighting and circling stuff. Because this one's not written down, you just have to watch. Okay. So a degree 3, when you draw it, will have 3 arms. Here's what I mean. So this graph in red here, 1, 2, 3. Degree 3, 1, 2, 3. 3 arms. A linear graph, x to the power 1, 1 arm. Think about a quadratic. A quadratic is x squared. Right? X squared, 1, 2. X squared, 1, 2. So you can combine all of this and actually draw a pretty accurate picture. Here's what I mean. Pretend for half a second that you can't see this picture. So just pretend that you can't see that, okay? And pretend your calculator just died and you're in the diploma and you didn't bring an extra set of batteries or a backup calculator and you're like, okay? So what do we know? Well, the constant term is 2. So we know we have a y-intercept at 2. Okay? We know the leading coefficient is positive a half. So the graph has to finish by going like that, right? So all I have to do is go whoop, whoop. Now, it could be this, it could be this, it could be this. It doesn't matter because they all have they're all smiles, right? So I can draw a somewhat reasonable approximation by knowing y-intercept, leading coefficient, and number of arms. Because it's a square, it's got to be a smile or a frown, right? So it's just 2 arms. So whether or not I know where it bottoms out at, whether I know how many x-intercepts it has, that you have to use your calculator for. But in terms of just a general shape, you can get there by knowing these patterns. So why should you care about the general shape? Well, a lot of you, not a lot of you, sometimes you guys get in the habit of as soon as you start punching in buttons on your calculator, you kind of let your brain relax, right? You just kind of go on autopilot. Well, let's say you're looking at this equation, and let's say you ended up, so you hit graph, and you ended up, let's say, with this. You should look at that and go, whoa, hold on, hold on, hold on. That was not what I thought should happen. I thought I was going to have a positive y-intercept, and I thought this thing was going to go like this, right? It should have gone like this because of the positive half. And instead it's going down. So that tells you to go back and check what you plugged in. And you're like, oh, I plugged in part C when I should have plugged in part B, right? How many times do you do that? So if you're thinking about what the picture should look like before you even hit the graph button, it will greatly cut down on the errors that you have, hugely. Okay. Okay. I don't know how big of a deal this concept is, but we'll talk about it here. Is the maximum number of x-intercepts. Okay, so maximum meaning like how many can they have at most. So linear graphs, so lines, right? It's a degree 1, and the maximum number of x-intercepts it can have is 1. Okay. Quadratics. Quadratics have a degree of 2. Now, from what we did yesterday, there's 3 possibilities when you draw a quadratic. You could draw this. This one has 2 x-intercepts. You could have this. This one has 1 x-intercept. Or you could draw this. This one has no x-intercepts. So the degree is 2. The maximum number is 2. Okay, I'm just going to stop there for a second. Linears have to have 1. Have to have 1. So every linear function will always have 1 x-intercept. Quadratics, x squareds, can either have none, 1, or 2 x-intercepts, the maximum being 2. Cubics can have the following. They can have 3, they can have 2, or they can have 1. Cubics cannot have 0. They have to have 1, 2, or 3. So the degree is 3. The maximum number they can have is 3. But they could have 1, 2, or 3. Do you notice a pattern between the degree and the maximum number? It is the same. What do I want you to get out of that? Linears have to have 1. That is a non-negotiable. Quadratics can have 2, 1, or 0. Cubics can have 3, 2, or 1, not 0. The maximum number cannot be more than the degree. So for example, a quadratic cannot have 3 x-intercepts. The most it can have is 2 because the degree is 2. Polynomial cubics, the maximum they can have is 3. They'll never have 4 or 5 or 6. So you can't have more x-intercepts than the power of x. So if you were in 30-1 right now, and I gave you an x to the 5th, what is the most number of x-intercepts you could have? 5. Okay, so the number of x-intercepts can't exceed the degree. So for example, what kind of question could this be on the diploma? Well, they could give you a random polynomial function, and they could give you 4 statements, and they'll say, which of the following is false? And it could be an x cubed, and it might say the number of x-intercepts could be 4, 3, 2, or 1, or 0. It's like, nah, you can't have more than the number. Okay. One thing to note, quadratics are the only ones that can have 0. Linears have to have 1. Cubics have to have 3, 2, or 1. Quadratics are the only ones that can have none. Okay. This is why I want you to focus on the picture, okay, not focus on all the rules. But I just want you to, I'm trying to take away the freakiness of all this language, okay? But at the end of the day, if you plug it in on your calculator, you should be able to make your way through it. Okay? I don't think there's too many more patterns. I think the rest is just questions here. Oh, turning points. Sorry, last pattern. Okay, so degree 1, degree 2, degree 3. Okay? This is what this graph looks like. This is what this graph looks like. This is what this graph looks like. Turning points, remember, these are your peaks and valleys. Okay? Does a straight line have any peaks or valleys? Nope. Quadratics have one turning point. Either they'll have a peak or they'll have a valley. Cubics, this one has a peak and a valley, so it is 2. What's the pattern? So the degree is 1. Maximum number of turning points is 0. Degree is 2. Maximum number of turning points is 1. Degree is 3. Maximum number of turning points is 2. What's the pattern? It's always 1 less than the degree. So if I were to give you an x to the power of 6, what is the absolute maximum number of hills and valleys you would have? 5. Absolute max. Think about it. In order to get a hill, in order to get a peak, you need 2 arms. 2 arms to give you 1 peak, or 2 arms to give you 1 valley. You need 2 to get 1. It's always 1 less. Okay? That one I don't really care about too much, right? Because honestly, with that one, you're just going to draw the picture and you're going to count, right? So, okay, let's just do some questions. That's enough theory. Let's just put all this together. So you will need a calculator for this. So if you don't have one, okay. So can you do this from memorization? Yes, but let's not. Okay, let's just use our calculator. Long weekend's coming up, right? We want to think as little as possible. I swear though, for some of you, if you guys put half the effort in that you do into planning that camping trip, you would be scholars. Like just yeah, there's no fire. So you got to find propane pits. So, okay. Yeah. Okay. So if you plug this thing in on your calculator, you should get out something like that. Okay? So make sure here you're using the subtract sign, right? So you're going y1, 3x, subtract 5, hit graph. Okay? So what is the number of x-intercepts? Not what are they, just how many are there? There's 1 x-intercept. So it didn't ask you to actually find it. It just says, what is it? Like, how many are there? Okay, so the y-intercept. So you can either go number 1 value, make x equal to 0, or you can look at what part of the equation? -5. It's just the constant term. You can also just look at the picture on your screen and see that it goes through -5. Okay, if you've got good enough eyes. Okay, end behavior. So remember quadrant 1, quadrant 2, quadrant 3, quadrant 4. So from the left side to the right side. So the end behavior, it goes from quadrant 3 to quadrant 1. So on the diploma, it will say extends from quadrant 3 to quadrant 1. You don't need to write all that in, just write quadrant 3 arrow quadrant 1. Domain. Does this go forever to the left and forever to the right? Does this go forever down and forever up? We love lines. That's why we start with them in grade 10. How many turning points? Any peaks or valleys? No. So this is all we're doing today. Okay? Easy peasy, right? You caught up to me? Okay, so same thing. Okay, so let's plug this into y1. Okay, so it's -2x squared, subtract 4x, and then what does it finish with? +8. Okay, so before I do anything, don't hit graph, don't ruin it. Where do you expect the y-intercept to be? +8, okay? It has a -2 as the leading coefficient. So is it going to finish going up or finish coming down? So since it's finishing coming down, is this going to be a smile or a frown? A frown. Look at that. Okay. So again, doing that little checklist in your head is entirely optional, but it does help you cut down on your mistakes, right? If you accidentally hit the negative key or the subtract key. So number of x-intercepts, 2. Now let's just review here. Do you remember how to find them? We talked about this yesterday. If you were actually asked to find the x-intercepts, do you remember how you would do that? You go second trace, you pick number 2. Okay, let's go through and do it actually. Let's just pause here. Okay, so we're looking for this number here, and we're looking for this number here. Now, unfortunately, the calculator can only find one of them at a time, so we have to do the process twice. Okay, so go second trace, pick number 2. Okay, now look at the prompt at the bottom. This is a left question. So right here by my pencil tip, so this is what I'm looking for, this point right here. Give me a number on the left side of it. -5. Now, be careful here. Now it's going to say right, but you can only be to the right of one of them, not the right of both. So when it says right, your only choices are 1, 0, -1, -2, or I guess -3. You could go -1.5 as well, but you can't be to the right of this one. Okay? If you did, if I wrote in 7, so it had 2 x-intercepts, it's going to hit you with an error because it doesn't know which one you want it to find. Okay? So I'll just go with -1. What do you do with guess? Hit enter. Now, what does E mean? 0. So the x-intercept is at -3.24 or -3.2, however it wanted you to round. We would then repeat the process. Second trace, pick number 2 again. Now, this is what I'm looking for. So give me a number on the left side. I'll go with 0. Give me a number on the right side. I'll go with 7. Most useless feature ever. 1.24. Okay. So -3.24 and 1.24. Now again, that was not part of this question. I just wanted to review the button pushing. It is, okay, I've got bad news. And they don't do this in 30-2, but they do it in 30-1. Technically, the diploma is allowed to ask anything from your entire 12 years of schooling. No. So even though we, let's say, don't talk about slope in 30-2, could they actually put a question of slope on there? Yes. So even though we are not talking about finding the x-intercepts, did we cover that in Math 20-2 and in 10C? Yes. So technically it's fair game. Will they make you find it? They could. I don't know. But that's why we review some of the, like, are they going to ask some random thing that you learned in grade 5? No. They're going to ask overarching concepts. So do we find x-intercepts throughout this course? Like, have you found an x-intercept throughout this course? Yes. Doesn't matter that you haven't found it in this unit, right? So for example, in the exponents and logs unit, we talked about asymptotes, right? Those lines that you don't ever cross. Could they ask you an asymptote question with a polynomial? Yes. Will they? No. But they could. And in 30-1, they very well might do that, which is what makes that course so nasty. Because you're not just having to memorize that course, you got to remember everything from past grades as well. Okay, y-intercept. I hid the equation, but the y-intercept is right here. It was the constant term. Okay. So end behavior. So the left side is quadrant 3. The right side is quadrant 4. So you go quadrant 3 to quadrant 4. You always go from left to right. Okay, is this graph going to continue getting wider and wider and wider and wider? Yes. So the domain is all the reals. By the way, for polynomials, regardless of the shape, the domain will always be all the reals. I'll say that a little louder. It doesn't matter if you have a line, a quadratic, or a cubic. The domain answer every single time will be x is real. Okay? It is the range that mucks up. So the range This is the top. The top is not at 8. The top and the y-intercept are different. So I need to find the top. Yesterday we learned how to do that by using number 4, because we're going to use maximum because it's at the top of my curve. So, second trace, number 4. Same instructions, but this is the point that we're looking for this time. So give me a number on the left side. -7. Yep. Give me a number on the right side. Hit enter to get past guess. Okay, so where is the top of this graph at? 10. Okay. Okay, so the top of this graph is at 10. Now, listen to the question. Is this whole graph, are the y values on this graph smaller than 10 or bigger than 10? Smaller. So you're going to write y. You write the small end pointing to the y, and then you write 10. How many peaks and valleys? 1. 1 peak right here. It's what we call the vertex. Okay. Okay. I'm going to go quiet. You guys try this one. Okay. Okay, let's go through these answers. So number of possible x-intercepts. So that is 3. Okay. Y-intercept, you can either look at the picture or you can just look at the constant term and you can see that it's at -10. This is quadrant 3. It's going this way on the left side. This is quadrant 1 on the right side. So it's going quadrant 3 to quadrant 1. Domain. Okay, so even though you can't see the top, you know it's here. But this continues this way and this continues that way. I said to you before, domain, don't even think about it. Everything in this unit is x is real. Okay? Range. Yes, this is a bottom, but it's not the bottom. There's no bottom. This is a top, but it's not the top. There is no top. So it's y is real as well. And then turning points, we've got 1 peak, we've got 1 valley, so it is 2. Now, there's a part B to this question. And this is a typical, so you've got the long answer questions on the diploma, right? So on a diploma, this could be question number A. So it could be, here's the equation, give us all the properties. And then part B might be and written a sentence. So it says, how would you alter the equation to get a different end behavior and a positive y-intercept? So what would you do to get a different end behavior? What would you have to change? So this is going up, right? Look at the leading coefficient. The leading coefficient is +2. So yep, so what you want to do, so for the end behavior, you want to make the leading coefficient negative. How about getting a positive y-intercept? What would you have to change in that one? What does the y-intercept match in the equation? It matches the y-intercept matches the constant term, right? So right now my y-intercept is -10. So if I want a positive y-intercept, what would I do? You'd make the constant term positive. So that is a typical diploma exam question because it forces you to know the pattern. Now, Are you screwed if you don't know the pattern? No, because you have a calculator. Could you just start changing numbers in their y1 until you get the condition to happen? Yes. So you would just say, I would change the equation to this, and then I would have I would end up with end behavior being this, and right? They're looking for the pattern. So you probably wouldn't get full marks if you just said, I made up a new equation and this is what happened. So unless you relate it back to actually the leading coefficient in the constant term, they're not going to give you full marks, but they'll give you part marks. They could, yep. But it's a sketch. You're not plotting points ever, it's just a sketch. But know this, and I mentioned this in the exponents and logs unit, if you're going to draw the graph, you must indicate the window settings beside the question. We have to show x min, x max, y min, y max. It is not enough just to put the numbers on the grid. You have to list the window settings beside every picture that you do. It's frustrating. It's a hoop. Okay, so here's a little question. It's matching. Okay, we love matching. Now, let's see if you can do it without plugging them in on your calculator. Oh, okay, so let's start with the lines. Which two equations are lines? H and Q. Okay, so you know it has to either be 1 or 3, right? The tricky part with this is that they both have the same y-intercept of -3. So that really doesn't help us. So on this one, the really only way that you could do it is by plugging it on the calculator. Okay, so if you plugged it onto the calculator, this one would be Q and this one would be H. But that's really only the way you could do it is by using your calculator. But at least you could narrow down your choices. Okay. Okay, let's do the quadratics next. So let's find our smiles and frowns. Okay. So we know it's got to be graph 2 or graph 5. So let's see what we can do here. Okay. What does the number on the end match again? What does the y-intercept, right? So this is the y-intercept. Okay. See how they're different numbers? So because they're different numbers, we just have to match up the y-intercept. So this one has a y-intercept of 1. This one has a y-intercept of -2. So this one has to be J, and this one has to be K. Okay. Finally, this one and this one. Okay. Now this one, it doesn't help us to look at the y-intercept because they both have a y-intercept of -2. That doesn't help us. Okay? So now look at the leading coefficient. This one has a negative leading coefficient. This one has a positive leading coefficient. Remember, leading coefficient tells you how the graph will end on the far right side. So this one's going to go down, and this one's going to go up. So this one goes up, so that's P. This one goes down, so that is G. Now, you can plug all those in on your graphing calculator, all 6 of them, and play math match. That will take you substantially longer than what we just did, but you're 100% within your rights to do that. So beside the question, how would each graph change if the sign of the leading coefficient was changed to the opposite? So if this one was changed from negative to positive, if this one was changed from negative to positive, if this one was changed from positive to negative, what's going to happen? It's just going to reverse how it ends, right? So this one, instead of going down, it's going to go up. This one, instead of going up, it's going to go down. This one, instead of going up, whatever it looks like, it's going to go down. This one, instead of going down, is going to go up. It's just going to flip it. right? It's just going to reverse the direction of the end. So at the right. Okay? Okay, I think that's it. Okay, so go for me, please, to page 337. Okay? So while you are just circling those questions, I'm just going to write this out up here. Okay, so there's the assignment. Because number 8 on page 337 is classic diploma. Classic diploma. Okay? So if you look at number 7 on page 338, see it's a matching question, right? Classic diploma. Number 8 on page 339 and number 9 on page 339, those are numeric response, classic diploma. Okay? So what makes question number 8 such a classic diploma exam question? The fact that they gave it to you all in letters with no numbers is what makes this diploma worthy. Okay. So, first things first. You need to understand that those two are going to be lines, and these two are going to be smiles or frowns. That's step 1. Why is that important? Well, when you look at the 8 pictures above the question, you have 4 smiles and frowns and 4 lines. Okay, so at least you know where to focus. So if you had to do a random guess as to what the lines matched, you would not pick graph number 2 for the first equation, right? So at the very least, you can do that for yourself. So how do you survive this question? Honestly, graphing calculator, but you need to know how to do it. The key to this is knowing what the heck that statement means. A, B greater than 0. This means A and B have to be positive numbers. A, B less than 0 means A and B have to both be negative. A, C greater than 0 means that A and C are positive. A, C less than 0 means A and C are negative. So all you have to do is pick, for number 1 here, pick 2 positive numbers for A and B, and then use your calculator. So for example, make A 2 and make B 5. And when you punch that in, you will notice that it matches graph number 5. For this one, you have to pick a negative A and a negative B. So negative 2x subtract 5, or plus negative 5. I don't care how you do it. And that one, you should get out graph 8. Now, how am I doing that? Constant term. Whoops. Whoops. Okay. Constant term. What does the constant term control? the y-intercept. Okay? This is the leading coefficient. So this is positive 2, so the graph has to go like that. This one's negative 2, so the graph has to go like that. So if you didn't want to use your calculator, could you use the patterns to match it up? Yes. The point is that you have to know what the notation means. That is diploma. So here, A and C have to be positive. Did they put any restrictions on B? So you can make B any number that you want. So you would go, A has to be positive. I'm going to make B be whatever I want. And then C has to be positive as well. So if you plug that into your calculator, you should get out number 4. Nope, number 3. Okay. Now, how do you know that? Because this is going to be the y-intercept, because that's the constant term. And this is the leading coefficient. It's positive, so you know it's going to go like that. So you're looking for a positive y-intercept, and it has to finish by going like that. So whether or not it looks like this or like that, it doesn't matter. For the last one, A and C have to both be negative. So negative 2x squared, anything I want, and then negative 5. So this means the y-intercept has to be negative 5. The leading coefficient is negative, so that means it's going to go like whoop down. So you're going to go whoop like that. Pick the one that matches. 2. Okay. So notice the question says, write the graph number in the first box. Write the graph number in the second box, right? Nothing is up for interpretation. So can you totally fake your way through on the calculator? Yes. Can you use patterns? Also yes. What is not negotiable is understanding what on earth the question actually says. So question number 9 is the same idea as this. And then when you go to the second assignment, question number 1 is the same as this. Okay, so 7, 9, and 1, that is what you're going to focus your attention on. Okay, and then on the second assignment as well, question number 3, it's a true-false question. And the diploma loves true-false because what they will do is they'll give you 4 statements. They'll say put a 1 beside the question if it's true, put a 0 beside it if it's false. So statement number 1 goes in box number 1. Statement number 2 goes in box number 2. So it might be true, false, false, true. So you would go 1, 0, 0, 1. Okay. All right.